One more example from the quiz, or from the homework. The inequality -1 less than negative x over 3 less than 1. How do we solve this inequality? We multiply through by -3. Anytime you have a denominator in an equation or an inequality, multiply through by it. Multiply through by a common denominator. And it's going to clear all your denominators and make the inequality or the equation much easier to deal with. So if we multiply by -3, and remember to reverse sign since we're multiplying by negative, and everybody seemed to be pretty good about remembering that. Then we get 3 greater than x greater than -3. Now making the inequalities go this way, we flip everything here. We get -3 less than x less than 3, same thing. And we graph the solution, so that's pretty straightforward. Now turning to the questions on the document. We had, or we should have had, I didn't enter it quite correctly, but what was intended was we're supposed to solve the equation x plus 4 quantity squared minus 25 equals 0. Well, one way you could do this is go ahead and expand this, and then having expanded it, you could try to factor it, or you could use the quadratic formula. It would factor, and the quadratic formula would work just fine, but we can solve it in this form somewhat more easily by simply adding 25 to both sides and then taking the square root. And of course, since we have the square equal to 25, the result will be equal to plus or minus the square root of 25, which is plus or minus 5. So x plus 4 is either 5 or it's -5. If it's x plus 4 is 5, then very straightforward, the solution is 1. If x plus 4 is -5, the solution is x equals -9. Our solution set is 1, -9. Had we expanded this and factored, we would have come up with the same solution set, assuming we did it correctly. And had we applied the quadratic formula, same thing. We would have obtained the identically same solution set. Okay, now let's look at the equation x to the 4th minus 81 equals 0. There are two ways to solve this. Okay, one way is to factor it. Okay, x to the 4th minus 81 is the same as x squared minus 9 times x squared plus 9. Make sure you convince yourself of that and understand that that's just the result of a special formula. The special formula for sum and difference of two binomial. The special formula for the difference of two squares. X to the 4th being the square of x squared, 81 being the square of 9. Sorry, it's getting a little late. I think I probably need to go home and eat supper. But okay, so we have x squared minus 9 times x squared plus 9 equals 0. We can't factor x squared plus 9, but we can factor x squared minus 9 into x minus 3 times x plus 3. And then our solution, since all this is equal to 0, is either x minus 3 has to be 0, or x plus 3 has to be 0, or x squared plus 9 has to be 0. Now we'll observe immediately x squared plus 9 can't be 0 because x squared can't be negative. And the only way you're going to add something to 9 and get 0 is if that thing is negative. So there's no way this one gives you anything that's added to the solution. But this equality obviously has solution x equals 3. This one, x equals -3. So our solution set would be the set 3 and -3. 3 or -3. Another way, x to the 4th would equal 81, just adding 81 to both sides. So we could say, okay, well, that's fine. So x squared then would be plus or minus 9. Since x squared is the square root of x to the 4th, then x squared is going to be plus or minus the square root of 81. And that's pretty straightforward. And if x squared is plus or minus 9, then x squared is 9 or x squared is -9. Well, x squared can't be -9 any more than x squared plus 9 can be 0. X squared can't be negative. X squared equals 9 gives us x equals 3 or x equals -3. So again, we have solution set x equals 3 or x equals negative 3. Another question, for what values of x is the square root of 2x, is it possible to calculate the square root of 2x plus 7? In other words, for what values of x does this quantity or this expression make sense? Well, if 2x plus 7 is greater than or equal to 0, then we can take its square root. Otherwise, we can't, because otherwise 2x plus 7 would be less than 0. If 2x plus 7 is less than 0, we have a negative here, and we can't take its square root, at least not over real numbers. Well, 2x plus 7 greater than or equal to 0 tells us x is greater than or equal to negative 7 halves. So all these values are good. We have to exclude all other values, and that would be all values of x which are less than negative 7 halves. So these values are good. These values are in the domain of this expression. These values are excluded from the domain. Similarly, square root of x squared minus 9 makes sense as long as x squared minus 9 is greater than or equal to 0. That is, x greater than or equal to 3 or x less than or equal to 3. We want to exclude negative 3 less than x less than 3.